Next up, we're thrilled to welcome Chu-Cheng Hsieh. Chu-Cheng Hsieh is the Chief Data Officer at Etsy, where his primary responsibility is to deliver strategic and creative data science approaches that help achieve Etsy's mission and goals. He develops the Etsy data strategy and specializes in search engines, recommendation systems, and machine learning. Chu-Cheng received a PhD in computer science from UCLA. Chu-Cheng, over to you.
My name is Chu-Cheng Hsieh. I'm Chief Data Officer at Etsy. Etsy is an e-commerce marketplace for many handmade and vintage items. And as you can imagine that a company like Etsy, to create a marketplace, we have to solve many problems using machine learning and AI. And for those of you who are practitioners at this AI space, you probably already know or hear that people are saying data is the new oil. And today I'm going to talk about how can we build an oil refinery to translate data into product that bring revenues. Speaking of data is the new oil. Did you know that the fabric we wear today is actually made from petroleum? Yes, petroleum. Similarly, many products like auto driving or e-commerce are all powered by data under the hood. Let me show you an example. If you visit Etsy today, what do you see are many modules driven by data. The first landing page you arrived, you are going to see a lot of interaction between you and the computers. Because I'm researching face mask recently, the website using my search history and my behavior data to generate a few ideas for me. It will invite me to interact with the system to learn more about my style preference. Eventually, with all this data, I will be able to have a personalized experience. And today, I'm going to take you with me to see the entire data journey. I will use a 6-layer data framework to explain how we build a data refinery. Yep, I'm going to share many things, including my battle scars. I want to share with you about lessons I learned from my career. And hopefully, you could save millions of dollars by leveraging the lessons. If you are a business executive, I want to help you decipher the mystery behind the scene. You will know the data lifecycle and what your CDO is trying to accomplish. I want to help you to connect the dots. Why? Because when things go wrong, you will at least know who you should talk to, or better, you will have good instinct on what's going on. So let's first take a look at this framework. To begin with, from the very bottom, we will talk about how data are generated. When I say generated, which I actually mean is how they are collected. Walking up this pyramid, we will dive into each stage and help you to connect the dots. There will be 6 layers. On the right-hand side, I have a surprise for you, so let's leave that for the future. Before we jump into the detail, I want to encourage you to give some thoughts on why and the rationale of each layer. Why? The technology we choose evolve over time. I still remember 20 years ago, programmers write everything in C++ or assembly language. But today, hey, many scientists or data engineers are only writing programs in Python. Technology and solution evolve over time. So, shall we? Let's dive into our first layer. Layer number 1, collect and monitoring. Of course, you have to first get data before you build anything on top of it. The rationale is very intuitive. We all need the data. Let's first take a look about this picture. What's come to your mind? What did you see? Well, the quantity of both sides could be similar, but the quality is very different if you ask people doing recycle. So I want to share the first important lesson, which in layer 1 is that the quantity and the quality of data are equally important. If you ever build a product based on machine learning later, you will know this popular statement: garbage in, garbage out. You don't just want to collect a lot of data. Many companies say they have lots of data, but that's talking about quantity, not quality. You want to make sure you get your data organized and clean. So how can you get clean data, and what is clean data? Well, data collection usually consists 3 key components. Firstly, you have to connect as many data sources as you can. And this is more like the rule number 1. Secondly, you have to check every event. Don't filter any data at this stage. What you want is to get as many information as you could. And lastly, you have to figure out a mechanism to do data quality check. Among these 3, the data quality check is often the missing part. I would like to share a story from a close friend. Long time ago, his company checked 3 phone types. When you use their website, they will record are you using an iPhone, an Android phone, or something else. And one day, one developer decided to add a new type called iPhone Pro. Of course, iPhone Pro was not on the market yet. But guess what? Because he didn't touch the word iPhone, so no one really cared he added new more type. Usually, if you add something new without touching the existing types, that won't break anything. His code was checked into the system because iPhone Pro was not released yet, so when you run tests, everything is normal. Nothing gets impact. Unfortunately, a few weeks later, the executive team, when they review the monthly metrics, they are in panic mode because they see the daily user number, especially the iPhone user, is dropping sharply. And you know it's not real. They just create a new type to collect those data. We have code review, we have unit test, integration test, and sometimes you will have an analytical team to double check the business KPI. But still, what people often neglect is there is a time delay for data to flow in. So what can we learn from here? Well, no one intends to do any bad things. But the good intention won't be enough. You need to build some safe belts. For example, you need to at least check 3 things. The 3 things I recommend you to at least check are missing values, schema change, and inconsistency. If we have schema change here, we could avoid the previous problem I just shared with you. I also want to briefly touch upon inconsistency. Inconsistency here is a very broad concept. It refers to data drifting, such as seasonality during holiday season, or it can be defined as any unexpected distribution change in your data ingestion systems. And remember, if you don't set a priority to make data reliable, your data is not going to be trustworthy, and that is going to be a big problem. We will come to this problem again in the later stage. But before we talk about the problem, let's go to the next level. Once data is extracted from its source, we usually have to convert and save them into a usable format and load into a system for analysis. Popular choices these days are like BigQuery from Google, Redshift by Amazon, and Snowflake. The rationale of this layer is to ensure you have structured data that can be retrieved easily and systematically. The best way to understand the rationale of this layer is to imagine that you have thousands of Lego blocks. That's what you get from layer 1. Once you collect all the blocks in layer 1, you have to ensure all these data are structured in a way they can be found easily. When I say find or retrieve easily, sometimes it means that you can using a query language like SQL to get the information you need. Traditionally, company will have a team to take care of these operations. What operations? Three main types: extract, transform, and load. And we love to call these three operations ETL. The goal of ETL is to integrate data from multiple sources and save them into a central repository. Let me give you an example. In the website, I show you how I interact with Etsy. I'm going to touch many modules, like I favorite these items, or I click next pages. And we will have to have an ETL process to connect all my activities. Why? If I add an item at job and decide to pay it and check out on my way home, we need to somehow have a system to connect everything, so later on you can easily find all activity by me. If your company has a dedicated group responsible for this ETL process and they hire many data engineers, that team's main charter is to serve the second layer in this framework. When I exchange ideas with other tech executives, I noticed that a common mistake at this layer is forget to pay attention to metadata. Why? Let's put it in this way. When you process raw data using ETL to give it some structure and meaning, unintentionally you create new data. When you create new data from raw data, you give some new meaning to it. Here's the key. You want to make sure your meaning is explicitly spelled out. And that's why you need metadata. What is metadata? Metadata is data to describe data. I know, sounds a bit kind of confusing. So let's give a simple example. A metadata should have information like author, file size, the date the data was created, and maybe some keyword or short description to describe how you generate the data and what the data can be used for. With metadata, well, we can move to the next layer, discovery and explorations. The rationale of the discovery and exploration is to ensure we will be able to find the data we need and avoid reinventing the wheel or rebuild the wheel. On the contrary, if your data ecosystem has no layer 3, to use data is like shopping something in a flea market. It's going to be a chaos and take a long time. I also believe that this is the best practice. If you could introduce data validation and catalog at these layers, you could build a dashboard to monitor the healthiness of your ecosystem. Of course, I know sometimes you have to make a trade-off. You cannot have resources to build everything. But fortunately, most cloud providers will have a solution for you. At Etsy, we partner with Google, and our system is on Google Cloud today. And they have a service called Data Catalog. Service like this could be your baseline if you don't have a team to build metadata or a catalog. At least you will have a searchabilities. While metadata management and data exploration is an important issue to address, I believe it's not fully solved yet. I personally have seen many startups trying to solve this challenge from different perspectives. And I'm expecting to see a lot of advancement in this area in the next few decades. Okay, so let's go to the next layer. Aggregation for reusabilities. I want to use our Lego example again. So you have a lot of blocks, you sort them, you store somewhere. But let's start thinking about application. If you want to build a Lego city, you probably will know you need a tree, a house, a few Lego men, walls, block like that. If you could have someone to pre-build all these mini modules for you, you could assemble them quickly and build a city. And city here means application if you are building a software product. And the beauty of data is that once you have data, as long as you can find that, using data is cheap and fast. Many machine learning solutions will also produce new data. Did you know that? Have you heard the word embeddings? You probably heard this word if you work with some scientists. A few years ago, some researchers come up with this new idea. And embedding, you can think of then a sequence of numbers that allow words with similar meaning or a picture with similar style to have similar numbers. So basically, they're using a sequence of numbers to map each numbers with either a natural language or pictures. So these numbers are actually data generated from image or language. And why this is useful. You don't have to really go through all the picture to find a similar style. As long as you store these embeddings or numbers somewhere, you can build an application like show me similar product. Because all you need to do is just find a picture that corresponds to a number that close to the item you are searching for. With these kind of numbers, anyone can build a solution like take pictures and then find an item in the pictures and then search website to find similar items you want to buy. Or if somehow an item is no longer available on the marketplace, you can use these embeddings to help you to find a similar product as a replacement. And here's the challenge, right? Generating these numbers is not an easy task. If you think ETL requires some expensive operation, a lot of machine learning is even more costly. You may need to use some advanced neural network technique, and advanced usually means more money, and it takes time, so it's not fast, it's slow. So the best choice here is to leverage something good but expensive, is for us to build once and try to reuse them again and again. And the place we store these output, we often call them feature stores. And features are something machine learning can reuse to build models. Any tech company that want to do machine learning will very soon realize they will need a feature store. Of course, feature-like embeddings are just output of a sequence of computations. So if you work for an analytic department, aggregation to you could mean something totally different. But still, you need some mini aggregation, like a daily statistic. So later you can use these metrics, this statistic, to build a monthly report. The concept at this layer is identical. Mini aggregation to boost reusabilities. Okay. So far, we have been talking about data, module, reusability, metrics. I know. It sounds weird that so many preparations and we haven't talked about machine learning. And that's the fun part. Proper preparation prevents poor performance. And let me repeat this again. Proper preparation prevents poor performance. Or people call this 5 Ps. It's not just the life lessons. It also applies to any data-driven enterprise. If you want to build a data-driven company, if you want using machine learning, data preparation, the layer 1 to layer 4, are very crucial to your success. And of course, the next step is straightforward. With all these preparation, you could now use machine learning to build a beautiful model. Hooray! Finally. The good news is that with proper preparation, building a machine learning model is not that difficult. You have so many tools available. Your scientists can use scikit-learn, TensorFlow, and any advanced technology they want to use or libraries. Of course, in reality, the devil is in the details. Since the focus of today's talk is about data framework, I won't dive into the ML life cycles. I want to have a quick takeaway. I want you to remember that do not forget to verify your hypothesis with A/B test. All machine learning are hypotheses. As long as you A/B test to ensure they behave the way you expected, you will be okay. So let's wrap up the data framework to our pinnacle of the pyramid. Here I write down insight, or some people prefer to call it action or strategy. While it is so exciting to see many products or designs are driven by data and machine learning these days, I feel it's very important to ensure the solution can be understood by humans. This ask contrasts with the concept of the idea black box. I remember probably a decade ago when computer arrived at a specific decision that bring up KPIs, we are all very excited and no one really care about what's happening in this black box. We know it works. But things change. Today in academic research named this area explainable AI. It is one of the hardest trending research area. You know, every company can be viewed as a large system. And most of the time, data machine learning aims to optimize only one part of the systems, not the entire systems. For companies that want to excel their peers, they have to win not only the short-term KPI, they also need to win on their strategies. So I want to wrap up this framework with another lesson I learned. I remember when e-commerce just started, scientists using machine learning to optimize search results. I'm talking about 10, 15 years ago. At that moment, the most important KPI is to optimize for click-through rate. Basically, we want to show items that people will click. Of course, cheap and on-sale items attract eyeballs. And guess what? Very soon, machine learning decides to show all cheap items on the first page. If you are creating a marketplace, everything you show on the first search result page is cheap, low-quality items. Oops, probably not a good idea. I'm using this example to highlight the need of the last piece of the puzzle, is to have insights. Insights from the data, insight from your machine learning. Insight aim to educate leaders to form opinions and influence business strategies. And I'm a firm believer that the data-centric organization is going to be the winner in the next few decades. And I'm not going to be surprised that many more companies will create roles like chief data officers as their data steward. I want to share some thoughts about the futures. My team, peers, and venture capital friends often ask me about what's the next big thing. And I also ask myself frequently, what keeps me awake at night when thinking about the future opportunities? And here are my answers. Observability, governance, and automation. Let's first talk about observability. If you ask the leader of your analytic department, or probably any analyst in your finance department, what their biggest pain point will be, I bet the data downtime is at the top of the list. What is data downtime? It means periods of time when data is partial, with errors, missing, or inaccurate. As a business leader, if I couldn't trust the data, that is a serious problem. And any data from this data downtime, I cannot trust it. Today, data ecosystem is very complicated, as it includes so many producer and consumer. Think about the 6 layer we talk about. How many producer? How many consumer? We have to fully understand the health of our data ecosystem so we can eliminate the data downtime by applying best practice. However, which practice are the best that could evolve very quickly? The next opportunity is governance. When I talk about governance, the first thing that comes to my mind is compliance. If you live in America, you must hear acronyms like HIPAA, COPPA, and so on. There are more and more federal laws that govern the collection of information online and how we can use that. Remember, these are non-negotiable mandates. We have to prepare this change in advance. And the last opportunity, I believe, is automations. Thinking in traditional software development. Today, we have DevOps to ensure we can ship software to production in minutes, sometimes seconds, and we can keep it run very smoothly and reliably. Every software engineer will tell the importance of having continuous integration and deployment, or CI/CD. But traditionally, this CI/CD concept cannot be used directly here because we are not just talking about code. It's code plus data. I think this problem hasn't been fully solved yet. Automation brings high availability, and high availability brings trust. So to wrap up my talk, today we talk about 6-layer data framework, and I also share 3 opportunities for you to think about. I'm so excited and feel optimistic about our futures. Like I say, data is the new oil, and that is a good thing. Thank you for coming to the talk.